Good evening. Today is Wednesday, January the 20th. Today in pre-calculus, we looked at a concept called partial fractions. I will share my screen and show you what this is talking about. Basically, we are reversing the process where you find a common denominator and combine several fractions into a single fraction. We're going to take a single fraction and convert it back to several fractions. So I'll share my screen here and show you an example. If you look at a problem here, we can look at a problem such as x plus 13 divided by x squared minus x minus 20. Now the concept here is once again to break this down into fractions. So the first thing we do is we factor the denominator here. And if you look at factoring the denominator, if I come down here, I can factor the x squared minus 20 into x minus 5 so I got x minus 5 times x plus 4. So what I'm going to do is I will come over here and I'll just do this on the freehand because it looks like it's going to be easier. So we put equals here, and then we have our two fractions with a plus sign between them. The first fraction has the x minus 5 in the denominator. The second fraction has the x plus 4 in the denominator. And then we let the numerator for here be a, and the numerator for here be b. Now, so what we're going to do, we're going to take this entire expression here, and we're going to multiply it by the x minus 5. I have x minus 5 times x plus 4. Now, if I multiply the left side of this equation by x minus 5x plus 4, it cancels the denominator because the denominator is exactly that. So if I come down here with my text now, so the left side is just going to be x plus 13, and that's going to equal to, now, if you look at the first term here on the right side, if I multiply x minus 5 times x plus 4 times this, the x minus 5's cancel, so I'll have a capital A, and I'll have parentheses x plus 4. And then the second term here with my plus sign, now if I multiply this x minus 5 times x plus 4 times b over x plus 4, the x plus 4's cancel, so I'll have b times x minus 5. Now, everything from here on is just a lot of algebra, so what I can do, see, I can do x plus 13 equals, and if I multiply, I get ax plus 4a, and I get plus bx minus 5b. Now, the key here is you have an ax and a bx. So you want to get your x terms together, and you'll get your constant terms together. So I have x plus 13 equals a plus b times x plus 4a minus 5b. Now, the key to this problem here is when you have an expression such as this, where you have a linear expression on the left and a linear expression on the right, the corresponding coefficients have to be the same. So you get here that a plus b, which is the coefficient of the x term on the right, equals the coefficient on the x term on the left. So I have 1 equals a plus b. And then the other equation here, since this 4a minus 5b is my constant term, and I have 13 here, see, so I can come down and, okay, I can say the next equation here says 13 equals 4a minus 5b. Now, if I multiply the first equation up here, if I go back to my freehand here, if I multiply this first equation here by 5, because I've got a minus 5b, and if I have a plus 5b, I can cancel them. So I have 5 equals 5a minus 5 or plus 5b. Okay, now, so then you can see that I have a plus 5b and a minus 5b, so my b terms will cancel, and I have 18 equals 9a. So a equals 2. And then if I go back and look at my other equation, if a equals 2, I say 1 equals 2 plus b. So I can get b equals minus 1. Okay, so I can come up here to where I have my a, and I can cross it off, and I can put a 2 here, and I can put a minus 1 here for b. So what I have done, as you see, as I talked about in the beginning, I have taken a single fraction and I have broken it back down into 2 other fractions whose combination equals the original fraction. Now, where this becomes very useful, if you get into the mathematics of calculus, this expression here on the right is much easier to deal with than the one on the left, because you have linear terms in your denominator here. Now, there's several other different types of partial fraction problems. I'll come back tomorrow and show you the other ones, the next example. But if you're looking at this, if you have not turned in your end of chapter quiz for chapter 5 or your mid-chapter quiz for chapter 6 now, you need to get that to me either in your OneNote or as an attachment to an email. If you have problems, please let me know, communicate with me, and let me know how you're doing. So I will stop the share now, and I will be back with you tomorrow to talk about what we did in class on Thursday. Remember, tomorrow is chapel, so our class will be a shorter version, but I'll still get back to you and let you know what we did.